In today's lessons, we're going to learn how to add and subtract rational expressions. Before adding or subtracting two rational expressions, you must have a common denominator. After you establish the common denominator, then you add or subtract the numerators and keep the common denominator. So if you look at example number 1, we're adding two fractions, 13a over 4a squared plus 5a over 4a squared. We already have a common denominator of 4a squared, so we're going to keep the common denominator and we're going to add numerators. So 13a plus 5a is going to give me 18a. After you add, you should look if maybe this expression needs simplification, and we can reduce 18 and 4 by 2, and we can reduce a with a squared. So that will give me 9 over 2a. Example 2 also has a common denominator of 16, and it's a subtraction problem, so we subtract rational expressions. So again, we're going to keep the common denominator and we are going to add numerators. All the expressions are numerators, so which means we're going to add or subtract, in our case subtract like terms. To avoid a mistake, I would really suggest writing the numerators with subtraction first before you start combining. So I have 9x plus 12, and I need to subtract 7x plus 2. The parentheses are needed around the second expression, since this whole expression is being subtracted from 9x plus 12. After that, we're going to subtract like terms, so 9x minus 7x will give me 2x, and 12 minus 2 will give me 10 over 16. And again, look for the common factors. So to reduce and simplify this expression, notice that 2x, 10, and 16 are all divisible by 2, so we can reduce by 2 to get x plus 5 over 8. And that's my final answer in simplest form possible. Okay, let's look at more examples. They're all different, so we need to do each type at least once. So if you look at example number 3, your focus should be in the denominator. The denominator of the first fraction is a squared. The denominator of the second fraction is 8a, and we are subtracting those fractions. So to get the common denominator, you need to have the same number of variables and the same coefficient in both numerators. So if you notice, in the first fraction, we have variable a, but we don't have an 8. So we're going to multiply the first fraction by 8 to create the common denominator. And if you look at the second fraction, and the denominator has 8 times a, but doesn't have a squared. So we need additional a to match with the first denominator. So we're going to multiply numerator and denominator by a. So now I'm going to have 32a over 8a squared minus 7a over 8a squared. Since now I have the common denominator, I can subtract numerators. So 32a minus 7a will give me 25a over 8a squared. So subtract numerators, keep the denominator. And now simplify anything that you can. 25 and 8 don't have a common factor, but a and a square can and do have a common factor of a, so we can reduce to get 25 over 8a. Okay, looking at example number 4, it's really difficult to decide what the common denominator can be. So before you look at the problem and you start looking for the common denominator, you need to factor anything that you can in both numerators. So if you look at the first fraction, we have k squared plus 16 over 5k minus 10. So 5k minus 10 has a common factor of 5. So let's factor this fraction. So k squared plus 16 over 5k minus 2. Okay, the second fraction doesn't have any common factors, so there's nothing to factor. So right now I notice that both denominators have k minus 2, but the first has 5. So I need to multiply the second fraction by 5 to have the same denominator. So remember, when you multiply a fraction by a constant, you need to perform that operation in both numerator and denominator. So now, right now, I'm going to have k squared plus 16 over 5 times k minus 2 subtract 20 over 5 times k minus 2. Now my denominators are the same, so I'm going to subtract numerators and keep the denominator. So that will give me k squared, and then 16 minus 20 will give me negative 4 over 5 times k minus 2. And then looking at the numerator, I noticed that I have a difference of two squares. K squared minus 4 can be factored into k minus 2 and k plus 2. And my denominator is 5k minus 2. Now I can simplify this expression further by reducing this fraction by k minus 2. So my answer is going to be k plus 2 over 5, and that's the simplest form of this expression. Two more questions. Example number 5, we are adding two fractions. Both of the fractions have quadratic, actually the first fraction has quadratic expression in it. So again, to reveal the common denominator, you need to factor anything you can in both fractions. So if you look at the first fraction, x squared minus 5, potentially that could be the difference of two squares, but 5 is not a perfect square, so that expression does not factor. So we're going to leave it as x squared minus 5. But now the denominator can be factored into the product of two binomials, which is x times x, and then we're looking for factors of 6 that are up to 5. And that will give me positive 2 and positive 3. Now, my second fraction has no common factors, no other expressions to factor. So now I notice that the first fraction has a denominator that consists of x plus 2, x plus 3. The second fraction has only x plus 2. So we need to multiply the second fraction by the missing factor of x plus 3. So we will multiply numerator and denominator by the same factor. So right now, I'm going to remember when we add or subtract fractions, we're going to keep the denominator. So my denominator is x plus 2 and x plus 3. Now my numerator, I am going to combine first by writing my numerators together. Okay, multiplying by 1 gives you the same expression. So now we're going to combine like terms in numerator, which will give me x squared plus x minus 2 over x plus 2, x plus 3. Okay, and then we look at the numerator, and the numerator has a quadratic function, a quadratic equation or expression, which potentially could be factors. So now we have to think of, do we have any factors of -2 that are up to 1? And we can factor that to be x plus 2 and x minus 1 over x plus 2, x plus 3. And I notice I have the common factor of x plus 2 that could cancel. So my final answer is going to be x minus 1 over x plus 3. And this is the simplified form of the addition problem that we had in number 5. Okay, example number 6. Again, first, factor anything you can, then look for the common denominator. So the first expression, first fraction, has a quadratic expression, which could be factor to be x plus 2, x plus 3, so factors of 6 that are up to 5, and then m squared. Oh, I'm using x instead of m, let me fix that. And then m squared minus 4 is the difference of two squares, so we can factor it to be m minus 2 and m plus 2. And then we are adding 2 over m minus 2. So notice that the first denominator has two factors, m minus 2, m plus 2. The second fraction has only m minus 2. So we need to multiply the second fraction by the missing factor of m plus 2. Okay, let me fix that. That was a little... and it's still, that's m plus 2. So now we are going to have, remember, keep the denominator at numerators. So I have m plus 2 times m plus 3 plus 2 times m plus 2. And now in this expression, what we can do, notice here I have m plus 2 and m plus 2 as a common factor. So I can factor that out. And the remaining factor is going to be m plus 3 plus 2 over my denominator of m minus 2, m plus 2. And of course we can simplify that more, and we're going to get m plus 2 times m plus 5 if we add 3 and 2 together, over m plus 2, m minus 2. I switched them, but okay, let me write them backwards. So the first one was minus, the second one was plus. Okay, get rid of the common factors. So the common factor is m plus 2, and the remaining are my answers. So m plus 5 divided by m minus 2. Oops. And it just keeps going. Let me fix that. I'm sure you guys can write this. I'm going to write it a little higher so it doesn't hit the arrow. So m plus 5 over m minus 2. And that is our final answer.